pectinate muscle, and you couldn't see them on the real sheep, which, by the way, you guys need to look at those real sheep. I know I ran around with one and you saw it for like 30 seconds. Probably don't have time today because we're going to do the AVO, but you've got to get a hold of that and know it. They'll be on the exam. This is the pectinate musculature right here in the atria. So just look for that. And it kind of shows you that here's the interior part of your auricles. Okay. So if we're looking at the ventral aspect of the heart, here's my pulmonary trunk right in front. So it rises up from the right ventricle, but it crosses ventrally right in front of your aorta, which will help you identify those on the sheep heart because they're not color-coded for you or anything. You still have to know them. Alright, so pulmonary trunk. Right here is my aortic arch coming from the left ventricle. In the back, we're going to see, there's my inferior vena cava. Looks a little different on the sheep. On the sheep part, if you notice that the superior and inferior vena cava are almost right next to each other because the sheep is a quadruped. Superior vena cava right here, both of those go to the right atrium. Stuff that wasn't on our list yet, but will be right here, this sulcus dividing the two ventricles is going to be the interventricular sulcus. On the sheep part, it was still covered in fat. There's an interventricular artery and vein traveling through there. If we look at the inside of a model, you can see that trabeculae carni really well on this model. We couldn't see it real well on the sheep in just a few seconds, but if you spread the walls of the ventricles of the sheep part open, you can see them. There's your trabeculae carni right there. So kind of a lacy pattern of muscle. The chordae tendineae, those are going to be real easy to identify. You just have to remember what they do and what they're attached to. So they're attached to the valves, and you have to tell me the name of the valves. So if you're in the left ventricle, what valve are those chordae tendineae attached to?
Bicuspid.
And on the other side?
Tricuspid.
And on the other end of them, what's that attached to? Papillary muscle. So we don't want the valves going back the wrong way. So we want to hold them stabilized and tight so that the blood can't move backwards. We want it going in one direction. So there's our chordae tendineae and associated musculature. We want to be able to identify the valves. Right here is that fossa ovale, left over from the fossa ovalis, sorry, left over from the foramen ovale. So what was the purpose of that? So that was between the two atria during fetal life. We had a blood connection there so that we can avoid the pulmonary circuit. So we're kind of avoiding the right ventricle there. So the blood could come back from the circuit to the body, go into the right atrium, go right to the left atrium, back to the body, instead of going to the right ventricle to the lungs that aren't operating. I hope everybody got a chance to see the ligamentum arteriosum. Did I show everybody that one in the sheep part? I meant to. I forgot it the first time, didn't notice until it's halfway done. Ligamentum arteriosum is a remnant of the ductus arteriosus. It's right here. Make sure you add it on. So ductus arteriosus arises from which aortic arch? Sixth. So if I put a piece of tape on here with the letter A and I said identify the structure, you know it's the aortic arch. If I asked you which aortic arch embryologically did it arise from, then I'm looking for what happened here at aortic arch number 4. So the left side gave rise to the aortic arch. The right side gave rise to right subclavian artery. And you just have to know those. And so the carotid arteries, same kind of question, those were from the 3rd aortic arch. We do want to do our blood typing. So you guys have a choice. You can do artificial blood or you can do the real thing. And I'd like to do it